look at another video dealing with, it says consider the following equation in the point. Find the equation of the tangent line to the graph at the given point. This is my number 3 on the practice test. So this is practice test for test number 3. Now, in this first section, we can do this by the limit method. I'm going to do one more of these by limit method, but if there's no instructions telling you how to do it, you can also use the power rule and any other rule that you want to use for this. So power rule or chain rule, whatever works best. But in this case, I'm going to use the limit method just because that's what we're kind of doing in this first section. You haven't learned the power rule just yet, but by now you've already done all the homework, so hopefully you're ready to do the power rule and any other rule that you want to use to do this. So if we do f of x plus h minus f of x all over h, I'm going to evaluate f of x plus h, so this would be f of x plus h is equal to 3 times x plus h all squared minus 9. So when you square that, this would be x squared plus 2hx plus h squared minus 9, distributing the 3 to each item contained within parentheses, 3x squared plus 6hx plus 3h squared minus 9. So now, once we have that, now we're going to actually perform the equation. So 3x squared plus 6hx plus 3h squared minus 9 minus f of x, which is 3x squared minus 9 all over h. I'm going to distribute that negative to each item contained within parentheses. I'll have this as a result, and I'm going to notice that the 3x squareds are going to cancel, the 9 will cancel, and I'll be left with 6hx plus 3h squared divided by 9, or by h, sorry, can't even remember, divided by h. Factor out the h, we'll have 6x plus 3h left over divided by h. I'll be left with 6x plus 3h. But as I remember, h is approaching 0, so the only answer to this would be 6x to be my derivative. That would be the slope of the tangent line at any place on this graph. Slope of the tangent line, we're looking for the slope of the tangent line, or the equation of the tangent line at that point. So again, using the equation of the tangent line, we're looking at y minus y1 is equal to m multiplied by x minus x1. So setting up for the point of -1 comma -6, we know we got y minus a minus 6 equal to m x minus a minus 1. This will be equal to y plus 6 is equal to m x plus 1. And what we need to know is what m is. Since we've done all the work to calculate the slope of the tangent line at any point on the graph, 6x is my slope. That's the instantaneous rate of change, slope of the tangent line, and also the very first derivative as well. So when I plug in a -1 in for this slope, so slope is equal to 6x. Now I need to operate it in a full screen, so sorry about that. So slope is equal to 6x at the point of -1. 6 times -1, the slope would be equal to a -6. So y plus 6 is equal to a -6. X plus 1. Y plus 6 is equal to a -6x minus 6. And then, so I'm going to subtract 6 from both sides, and y is equal to -6x minus 6 minus 6, giving me y is equal to -6x minus 12. So that would be the equation of the tangent line for that problem. Also within the second section, we're looking at problem number 4. So looking at problem number 4 of my practice test, we got f of x is equal to 1 over x to the 9th, And by now you know we have to change the form of this so we can move that to the top so I can apply the power rule. And you know the power rule right now is ddx of u to the n is equal to n times u n minus 1. So this will simply be f prime, or dy dx, whatever language you want to use. This will be a negative 9x to the reduced by 1, that becomes minus 10. So to answer this question would be equal to minus 9 over x to the 10, giving that a positive exponent. So that's good number 4 of your practice test. And look at number 7 within that practice test as well. It said g of x is equal to 4x squared plus 7x to the third, and this is a g prime at x. I'm just going to use power rule here again, which we know is u to the n ddx of u to the n is equal to n times u n minus 1. So the n comes out front. This would be 8x plus 3 times 7 is 21, x to the second. And we're done with that problem. Moving on to number 10. If we look at number 10, we got h of x is equal to x to the 9 over 2, and it's the only reason it's on here because this is a fraction. We got to know how to do fractions, so still using the power rule that we have up here, we're going to use the 9 over 2 x to the subtracted by 1, so I'm subtracting 2 over 2 from that, giving me 9 over 2 minus 2 over 2 gives me 9 over 2 x to the 7 over 2. And that's all we need. Great answer for that. Number 11 is not any harder, but we're looking to find the derivative of 16x to the 1/8. So 1/8 times 16 gives me a simple 2x to the subtract 1, so I'm subtracting 8 over 8 from that, giving me a negative 7 over 8, which is equal to 2 over x to the 7/8 with a positive exponent. Moving that down to the bottom. And number 12, we can look at, it says f sub t is equal to 9t to the negative 3 plus t, and again I'm using the power rule, ddx of n, let's say x to the n, which will be equal to nx to the n minus 1, just using the power rule. Now we'll actually perform the operation. S prime at t would be equal to a negative 3 times 9 would be a negative 27. T to subtract 1 from negative 3 gives me a minus 4, plus 1 coming in front giving me t to the 0, which is just plain old be 1. So this with the positive exponent will give me a negative 27 over t to the 4th plus 1. And that should work out good for that problem. And number 14, I notice I've got y is equal to 9 over 8 for x to the 3, and this involves rewrites. This would be y is equal to 9 over 8, and this would be x to the 3/4. Moving that to the top gives me 9x to the negative 3/4 divided by 8. And now I'm going to use the power rule again. So negative 3/4 times 9 gives you a negative 27 over 4x to the, and then times the 8 because 8's already there. And this would be x to the minus 4 over 4, which is minus 1, subtracting 1 gives you a negative 7 over 4. Now we have a negative 27 over 8 times 4 gives me the 32. and be x to the, bringing that down to the bottom, it would be a positive 7 over 4. Remember, a to the negative n is equal to 1 over a to the n with the positive exponent we did in the previous module. So that looks like probably a good answer for that one as well. And I'm probably going to stop this video.